Afternoon, ladies and gentlemen. So today we have a question that we want us to discuss. This is basically Managerial Economics, BEC 332. The exam paper is basically 2018. So we're going to discuss number 5. And number 5, basically this is Langragian. So number 5 reads, suppose a publisher has determined through regression analysis that its profit pi is a function of the quantity of newspapers and magazines sold. This is given by the following relationship: X newspapers and Y magazines. So that is the info that we have been given in the question. So we have been told that subject to X plus Y is equal to 12. So X plus Y equal to 12, basically that is the equation that we have been given. And remember, X plus Y, this is basically a linear equation. So we are told number A, determine using Langragian multiplier techniques the quantity of newspaper and magazines that maximizes profit subject to the constraint. So one thing that we need to know about Langragian, we need to understand that when we are dealing with Langragian, this is basically a technique for solving constraint optimization problems when we basically combine the original function and the constraint condition. So this here is what is referred to as the original function, and this is what is referred to as the constraint condition. So when we combine the original and the constraint condition, then we get what is called the Langragian multiplier, where in this particular context we always refer to the Langragian multiplier as lambda. So lambda is what always multiplies the constraint equation. So when we are to add the constraint equation plus the original function, we are going to get what is called the Langragian technician equation in this particular context. So let us switch to our board that we will basically use in solving this particular question. So we are told to determine using Langragian multiplier techniques. So for us to be able to do this, we are going to combine this original and the constraint equation. So in this particular question, we are going to add pi equal to 80x plus 100y minus 2x squared minus 3y squared minus xy. So this is the original function, and the constraint function in this case is basically x plus y equal to what? 12. So this is the information that we have been given in that particular question. So what do? We are going to first manipulate the constraint equation by making sure that 12 goes over to the other side, and we have x plus y minus 12 equal to what? 0. So this here is what is basically referred to as the constraint equation, where we are going to multiply the constraint equation with the Langragian multiplier, that is lambda. I know a lot of you basically know lambda from physics, specifically wavelength, where we know for sure that lambda, this is simply the distance between two successive crests or troughs. But we are not looking at physics in this particular context. We are going to look at lambda to be a Langragian multiplier. So we are going to use the Langragian multiplier technique for us to be able to determine what they basically want. And what do they want in this case? The quantity of newspapers and magazines that maximize profit subject to the constraint. So in this particular context, we are going to add the original and the constraint. So we are going to say 80x plus 100y minus 2x squared minus 3y squared minus xy plus, remember we are going to add, plus the lambda open bracket x plus y minus 12. So remember, this is basically according to the profit equation that is given in the original context. So what then do we do when we reach here? So when we reach here, we are going to apply what is called partial differentiation. In this particular context, remember, partial differentiation has been basically looked at in previous videos I made under the mathematics playlist. I will attach a link in the description of this video so that you go and watch partial differentiation and how to go about it. So remember, how are we going to do partial differentiation in this case? So you are going to differentiate each and every variable that is appearing in this particular equation. So we are going first to differentiate with respect to x. So we are going to say d pi over dx. So anything that does not have a variable x is referred to as a constant. So the derivative of 8x is basically 8. The derivative of 100y is 0. The reason why it is 0 is because 100y does not contain what? X. Anything that does not have an x will be referred to as a constant. Then 2x squared will be 4y. This guy will be 0. This guy will be what? Y, because the derivative of x is 1, and 1y, you can't write 1y, you are a mathematician. And the derivative of lambda is 0. So 0 times everything is 0. But remember, you have an x. This is math. If you want, you can basically distribute the lambda. So in this particular case, you are going to differentiate the x, and we know for sure that the derivative of x is what? 1. 1 times lambda is lambda. So we are going to put lambda here. Then the derivative of y, 0. The derivative of negative 12, 0. So we are done with respect to x. We now go with respect to what? Y. So it will be d pi over dy, which will be equal to the derivative of 8x, 0. The derivative of 100y, it will be what? 100. The derivative of 2x squared, it will be 0. The derivative of negative 3y squared is 6y. The derivative of negative xy will be what? Will be y. Sorry, will be x. And the derivative of x will be 0, but the derivative of y will be what? 1. 1 times lambda will be lambda. And the derivative of negative 12 is what? 0. So we now go to the last part. And the last part, in this case, we are supposed to differentiate the lambda. So it will be d pi over d lambda. So it will be equal to the derivative of 8x is 0. The derivative of 100y will be 0. The derivative of 2x squared will be 0. The derivative of negative 3x squared will be 0. The derivative of negative xy will be 0. But the derivative of lambda will be 1. And 1 times everything in this case will be the same. Why? Because if we were going to distribute lambda in this particular bracket, you will understand that this will be x lambda, and the derivative of lambda is 1, and 1 times x is basically what? X. That's why this bracket has assumed the original state of it, which is x plus y minus 12. So now what are we going to do in this particular question? So what we are going to do is something that is very simple. What is that? So if you look at everything in this particular case, remember the question says that determine using Langragian multiplier techniques the quantity of newspapers and magazines that maximizes profit. So in order for you to maximize profit, we need to subject the constraint by ensuring that d profit divided by dx is set to 0. So this we set it to 0 for us to be able to maximize profit. And d pi over dy, we also set it to what? 0. And d pi over d lambda, we also set it to what? 0. Why? Because we want to maximize profit subjecting the constraint to these principles of us equating them to 0. So in this particular context, we are going to say x 80 minus 40x minus y plus lambda equal to 0. 100 minus 6, sorry for that, okay, minus 6y minus x plus lambda is equal to 0, and x plus y minus 12 equal to 0. So we are going to break down these two equations as though we are solving simultaneous equations in 3 variables by using the elimination method. So how do we go about that? So it is basically a simple technique. How do we do it? So we say 80 minus, sorry, in this particular way, I will first group like terms. So I'll say negative 4x minus y plus lambda is equal to negative 80. 100, which I will take to the other side. So I'll say negative x minus 6y plus lambda is equal to negative what? 100. So we are going to solve these two equations using elimination method. So in this case, we are going to eliminate lambda because it is the easiest one to eliminate. So we are going to use the principle of same signs subtract. So negative 4x minus x, it is giving us negative 3x. Negative times negative, positive. Negative y plus 6y will give us positive 5y. And we know for sure that lambda minus lambda is 0. Negative times negative, positive. Negative 80 plus 100 is giving us what? 20. So in this particular case, we now get this and this guy, we solve them together. So we say x plus y is equal to 12 goes to the other side, it becomes positive. Then we make sure that the coefficients are the same. So in this case, I am going to eliminate y again. So if I'm eliminating y, I make sure that the coefficients are the same. So I put 5 there. So I will say negative 3x plus 5y is equal to 12. Remember, I am multiplying this times that which is down, and I say 5x plus 5y is equal to what? 60. And I subtract. So what is negative 3x minus 5x? It is basically giving me negative 8x, and 20 minus 60 is giving me negative what? 40. Negative and negative, they are going out. So we are going to divide both sides by 80. So x is equal to 8 into 40 is basically what? 5. So 5 is the value that we get when we want to maximize profit subject to the constraint. So in this case, again, we are going to get the value that we are from finding for us to basically find the value of what? Y. So we are going to say x plus y is equal to 12. Then the value of x is what? 5 plus y equal to 12. And we are going to equate like terms. So we say y is equal to 12 minus what? 5. So what is 12 minus 5? 7. So you can find the value of the lambda given the 3 equations that we have above. So the value of lambda, let us find it together. So we can pick any of the equations that we have above here. So we can even pick the first one, 80 minus 4. What's the value of x? 5. And what's the value of y? 7. And the value of lambda is not known, equal to what? 0. So we continue from here. 4 times 5, 20, minus 7 plus lambda is equal to 0. So you get your calculator. We are going to subtract 80 minus 20 minus 7. We are getting the value to be 53. So when 53 goes to the other side, the value of lambda becomes negative what? 53. So this is the value of lambda that we have. So let us now go to the second question. So the second question says calculate the firm's profit as this constrained optimum level. Calculate the firm's profit at this constrained optimum level. So how do you basically do that? So remember, the profit equation in this case is this here. So we are going to substitute. Where there is x, you put 5. Where there is y, you put 7. Where there is x, you put 5 squared. And where there is 7, you also put 7 squared. And where there is xy, you put 5 times what? 7. And when you do the mathematics, so I bet we are all mathematicians here, and I will save you the stress to basically punch your calculators, but I will go directly in saying that the answer you get is 868. So for clarity's sake, you can get a piece of paper and solve so as you can prove where 868 is basically coming from. So this is how you solve B. For C, we are told that give an economic interpretation for the level of the Langragian multiplier obtained at A above. Remember, the Langragian multiplier that we got is basically what? Negative 53. But one thing that you need to know is what is basically the Langragian multiplier in this question. So one thing that you need to know about the Langragian multiplier is basically the shadow price of the constrained equation. It basically tells us how much profit increases as the constrained equation is relaxed by 1 unit. So what is the conclusion? The conclusion is profit decreases by 53 for every increase in 1 unit of the constrained what? Equation. Your host, Golden Zulu.